Hi, I'm Sean Denbo. The project I'm working on this semester is Dr. Memory. Working on it with Brandon Clark. He just left for Thanksgiving, so he was unable to join me today. So I'll have him blog about what he's been working on. So from my last talk, I mentioned what my goals were. That was to knock out the WOW64 syscalls. So last time I reversed all the parameters to them. I've added info, I actually integrated into Dr. Memory about half of them. So in between that time, I've actually been focusing on a specific subset of those. Wanted to understand them a little more and actually get all the structs down to very small detail. And then there's also two syscalls I still need to add in handling for. Basically because Dr. Memory currently doesn't support large data types, so I need to add in special handling routines. So this is a subset of syscalls I've been looking at. It's actually implemented in user mode in NTDLL. These are the CSR, or client server runtime calls. And this is actually extensively used by the Win32 APIs, the kernel32 and user32. They're built on top of the ALPC, which if you remember from last semester, that's what I focused on. So these are basically the inter-process communications for Windows. So basically it abstracts that, and it basically hides the internals. That way it's easier on the developer. So all those syscalls that are, so the reason there are syscalls now for the WOW64 is because you need to communicate with the 64-bit process. Which is the client-server runtime subsystem. So I'm going to actually explain a little history on it and then explain what it does. And then I'll talk about some of the actual API calls for it. So it has a long history. Back in the older code base, it actually dealt with the GDI, so that was like Windows graphics. But nowadays, that for performance reasons, has been moved into the kernel. You can find a lot of the native calls for the GDI in Win32k.sys. So right now, the two main things I really want to focus on is what it's used for in Win7 is the console window management and process creation. So when you actually create a process on Windows, the first thing it does is it needs to set up a connection with this subsystem, and it does that issuing CSR client connect to server. Whenever the subsystem receives this request, what happens is it will first duplicate the handles for the process and thread. It will then allocate and actually fill in two structs, the CSR process and CSR thread. And from there, it's going to insert this into the list. So remember, this subsystem deals with managing these process creations, so it creates a list for them. So now for the actual API calls that deal with this. So once you have this connection set up, you can actually start communicating. One thing I didn't mention is this subsystem. It runs at the highest privilege, so it runs as system. So whenever you set up this connection, it's actually the first thing during this setup process, it's going to create this heap space called the CSR port heap. It's actually really cool. This is golden because you can now have a user mode process that's underprivileged to communicate with the system level process. So it creates a section map for them. So anytime you have to transfer large message data between the two, it'll place them in this section. So the communication, so after it's set up, you created this process, you can start talking with it. You can send these API messages for specific functions that the subsystem actually utilizes. So when it loads up, it'll load baseserve.dll, csrserve, and winserve.dll. And these just have a bunch of functions related to console management. So after you set up this connection, it's basically considered a full connection. You start communicating back and forth. And you can break it down into three types. You have your empty packet, short packet, and long packets. So empty packets is just when you want the subsystem to perform some type of action. These short packets, that's when your data can fit into these LPC packets. So if you remember from last semester, I talked about the port message structure fitting into that. And then the long packets, that's where it uses that shared memory I mentioned earlier. So So I worked on creating a test app I'm going to integrate into Dr. Memory using these calls. So can everyone read this a little bit, make it bigger?
Looks like it's clipping up the left a bit.
Yeah, it is. Still clipping off. How's that? A little better. Okay, so we'll go up. So the first thing I'll look at is that Git console handle. Some things are just easier to do in assembly. So what this is doing is the F segment points at your thread environment block. So the first one at offset 18 actually grabs the virtual address of that. And then at offset 30 of your thread environment block, that's grabbing your process environment block. And within that, you can then reference at offset 10 a structure called the process parameters. And then at offset 10 of that is the console handle. So just implementing a function to grab that console handle. And then right here, we just have some initializations. So the one thing I want to focus on is actually using these API calls. So we see here, process creation has already been set up. You can communicate with it, but we need to allocate that capture buffer. So that's going to hold our data. And after that, so the parameters for this one is telling you the number of message pointers in the request packet, and then this is just the size of the data. So for the capture message buffer, this is basically copies over the user data and actually sets your pointers. So you have the length and then the actual address where your pointer is. And then this is where you actually communicate with the subsystem. So this is going to call it. You have your API message, the capture buffer you recently allocated, and then this right here. So what this does is, remember those DLLs I said it loads up? These are the actual API. So I'm just grabbing get console title, since that's what the subsystem uses. Some error checking, and then you can print out the console title. So what this application is doing is using these CSR calls, is with the console management, is grabbing is retrieving the console title of the currently running console window. And then I just free it up. So yeah, pretty cool stuff. So yeah, that concludes the presentation. Anyone have any questions?
So, Pancras has done this with you're communicating with him, right?
Yeah, Brandon or?
Brandon.
Yeah.
Brandon,
Yeah.
and as well as I forget his name.
Derek?
Derek.
Yes. Yeah. So yeah, I already put in half of it. I'm working on these other things, so got to add in the special handling routines for those two syscalls, and then integrate more of this info and add the app suite. Brandon's been mostly learning since reverse engineering is new to him, so I've been catching him up on that.
As a result of these changes, that the program becomes more portable?
What changes?
The result of changing something about the system.
Oh, okay. So Dr. Memory, that's a memory debugger. But these system calls, everything that happens is in the kernel. You can't actually monitor that since you're in user mode application.
Oh, okay.
So the whole goal of what we're actually contributing to is reverse engineering these parameters. That way you can...
emulating what the
yes,
system calls
exactly.
do
You're
without
emulating...
without actually making the system calls in order to detect any errors that could go on in that space.
You still make the syscalls, but you emulate what's happening on the actual buffers. So we need to be able to document what are the parameters. So do you have a pointer going into an out buffer? So is the kernel going to write info to this? Is it going to initialize? So we have to document all of that.
Okay. And I think earlier there was some acronym that I don't know what it stood for that I think you mentioned.
Guessing ALPC?
Yeah.
Okay, so last semester I worked on this. So ALPC was introduced in the Vista and up, Before that, it was just LPC, which is local procedure call or local inter-process communication. That's basically, communication. It's little packets for the kernel to use. So the ALPC is just asynchronous, so non-blocking.
Okay.
Any other questions?
So that's like how different processes share data?
Yeah, it's how you can communicate with a different process. So like on, yeah. Any other questions?